Hello students, in the last video we learnt about thermal power stations. In this video we will learn about hydropower plants. Students, do you know the kinetic energy of flowing water? Or the potential energy of water at a height is another traditional source of energy? Yes, it is. Hydropower plants convert this potential energy of falling water into electricity. We already know that electricity generated by using water is called hydroelectricity or hydroelectric power. But this does not mean that water from stream or pond can be used to generate electricity. For the large-scale production of electricity, fast-flowing water is required. Can you think why the speed of water is important in the production of electricity? To generate electricity, water must be in motion. When the water comes in motion, the potential energy of stored water is converted into the kinetic energy, and then it converts to the electrical energy. More the kinetic energy of water, more is the electricity produced. In fact, 1/4 of our energy requirement in India is met by hydropower plants. As we know, for the generation of electricity from water, fast-moving water is needed. So what are the good natural sources of fast-moving water? Rivers flowing fast from the mountains are good source of hydropower as they have a lot of kinetic energy. The waterfall is also a good source of producing hydropower. However, there are very few waterfalls around the world that can be used for the generation of electricity. Since there are very few fast-flowing rivers and waterfalls which could be used as a source of potential energy, we built dams on various rivers for the purpose of generating hydropower. Dams are among the largest man-made creations on the earth. Do you know what other purposes of building dams are? Apart from generation of hydroelectricity, dams are also built for irrigation, water transportation, flood control, etc. To generate electricity, high-rise dams collect water from the flowing rivers, another source like rain, etc. When this stored water, which has potential energy, is allowed to fall from a height, it rushes down with a great force onto turbine located below. The potential energy of stored water is converted to kinetic energy of falling water, which in turn is converted into electrical energy. Nowadays, a large number of dams have been built all over the world. Tehri Dam, located on the Bhagirathi River, Uttarakhand, is the highest dam in India with a height of 261 meters and the 8th largest dam in the world. The Hoover Dam in United States of America is one of the best dams in the world. Now let us see how a hydropower plant works. Dams have a number of large gates to control the flow of water, which are called sluice gates. The water from these sluice gates flows toward the turbine located at the foot of the dam. When the water flows on the turbine, it creates a pressure on it and makes it to rotate at high speed. Since the water in the reservoir is renewable because it would be refilled by the rain, so we need not have to worry about its replenishment unlike fossil fuels. The rotating shaft of the turbine is connected to the generator. In the generator, the coil rotates in a magnetic field to generate electricity. Depending on whether the generator has slip ring or a slate ring, an AC or DC current is generated. The electricity is then transported using the high power transmission lines. Hydropower is a very efficient source of power. Some turbines have achieved an efficiency of even 95% and above. So students, we have learned in this video is kinetic energy of water can be used to generate electricity using hydropower plants. More is the speed of flowing water, more is its kinetic energy and more is the electricity. Flowing water falls on turbines and rotates it, which in turn is connected to generator, and this produces electricity. In the next video, we study advantages and disadvantages of hydroelectricity.